This is the last video clip on exponential equations. On the screen here we have solved the equation 3 raised to the power 2x plus 1 minus 18 into 3 raised to the power x minus 2 minus 1 equals to 0. We are solving this to further emphasize on how to solve exponential equations involving quadratic. Here we have 3 raised to the power 2x plus 1 minus 18 into 3 raised to the power x minus 2 minus 1 equal to 0. Of course, you can see quietly that 3 raised to the power x appears to be our joker, but how do we get it out? First, I look at the first term. I can compare 3 raised to the power 2x plus 1 to a raised to the power m plus n. And we know a raised to the power m plus n must have been obtained from a raised to the power m times a raised to the power n, which means 3 raised to the power 2x plus 1 can be reduced to 3 raised to the power 2x times 3 raised to the power 1, which means I can express this line as 3 raised to the power 2x times 3 raised to the power 1. I just use bracket instead of using multiplication sign. 3 raised to the power 1, I just leave it there. Minus, now here I have 3 raised to the power 2x minus 2. I have 3 raised to the power x minus 2. How do I reduce this? I remember that if I have a raised to the power m minus n, it must have come from a raised to the power m divided by a raised to the power n. Yes, which means my 3 raised to the power x minus 2 must have been obtained from 3 raised to the power x all divided by 3 raised to the power 2. So I replace this here. This is minus 18. I now write this as 3 raised to the power x and divided by 3 raised to the power 2 minus 1 equal to 0. Of course, this is 3 times. Now my 3 raised to the power 2x, using our multiple indices rule, we can take this and put 2 there. Yes, because 2 times x will give me my 2x, and that's my 3 written there. And this is minus 18, 3 raised to the power x divided by 9, that's 3 raised to the power 2, minus 1 is equal to 0. You will agree with me that 9 can cancel here 1 and 9 can cancel here 2. Wow, so that will give me, that expression can be written as 3 into 3 raised to the power x all square, that's the first term, minus, since 18 has been cancelled out there, we now have 2 into 3 raised to the power x minus 1 equal to 0. So now we have the expression written as simple as possible. All we now have to do is to find something to replace 3 raised to the power x, 3 raised to the power x, something like y. Take notes. How did I go about this? I'll repeat this again. We have reduced this to what? 3 raised to the power 2x times 3 raised to the power times 3 raised to the power 1. And 3 raised to the power 2x itself is the same thing as 3 raised to the power x all square, and then we multiply by the 3 that is still standing out there. So that gives us this line. That's how we arrived at this point. And then 3 raised to the power x minus 2, also 3 raised to the power x minus 2 was obtained from what? Or was reduced to 3 raised to the power x divided by 3 raised to the power 2, which is the same thing as 3 raised to the power x divided by 9. So that 9, that's the 9 there, that cancelled our 18 and gave us 2. So we have 2 into 3 raised to the power x. So now we say let's replace 3 raised to the power x with something that say y to simplify our expression there. So we now have here 3. In place of 3 raised to the power x, we have y squared minus 2y minus 1 equal to 0. So now we have a quadratic expression or a quadratic equation. We can easily solve this for y and then move on to solve for x. How do we solve for y? Yeah, 3 times 1. So we're going to look for factors of 3. That's 1 and 3. So we have here 3y squared minus 1y minus 2y. I'm simply solving the quadratic equation now. Equal to 0. Y is common there. So we have 3y minus 1. What is common here? Minus 1 is common. So we have 2y plus 1 equal to 0. Now solving this out. Sorry, this is a mistake. This is minus 3. Sorry, I have to take this all over. This is not correct. Our factors are 1 and 3. So let's take that again. This is 3y squared minus 3y plus y minus 1 is equal to 0. Please, sorry about that. 3y is common here. So we have y minus 1. And then plus 1 is common here. So we have y minus 1 equals to 0. And from there, we have here that y minus 1 times 3y plus 1 is equal to 0. Now solving this equation, we will obtain y minus 1 is equal to 0, which gives us y equals to 1. And then we have here 3y plus 1 equals to 0. And that gives us what? Which implies that our y is equal to minus 1 over 3. So we have that y is equal to 1 or minus 1 over 3. Now, that is for y. Remember, we are supposed to solve for x. But here we have that our y is the same thing as 3 raised to power x. So we'll look at when y is 1, what will be x? And when y is minus 1 over 3, what will be x? Let's look at that. So that's it here. We have y equals to 1 or minus 1 over 3. So the next thing is we know that y is the same thing as 3 raised to power x from this state. So when y is what? When y is 1, what will be x? So that means 1 is equals to 3 raised to power x. This is a simple exponential equation. 1 is equals to 3 raised to power x. How do I express 1 in terms of 3? I say, oh, anything raised to the power of 0. So I can say 1 is 3 raised to the power 0. And this is 3 raised to the power x. Okay, in that case, my x is equal to 0. Straightforward. And next I look at when y is what? When y is minus 1 over 3. Okay, minus 1 over 3 is equal to 3 raised to the power x. The best I can do here is minus 3 raised to the power minus 1 equals to 3 raised to the power x. I cannot equate this because this is minus 3. Now for a negative number this way, we cannot find the roots. So we simply say here that x has no solution. Has no solution. For now, at this level of mathematics, you are permitted to simply leave this as no solution. So I simply say that what? Our x is just 0. So that's it for exponential equation. Yeah. X has no solution there. So we say, I call it the complex solution. Therefore, we simply pick x as equals to 0. That brings us to the end of exponential equation.